Okay, so this is the exam to practice sheet, the solutions for that particular practice sheet. So exam to practice solutions. Okay, so the first question was simply to plot a couple of points. So let me draw out the Cartesian coordinate system. So here's my Cartesian coordinate system. And we were asked to plot the point A, which is at 5, 5, and then B, which was negative 3, 4. Remember, these are always x, comma, y. So to plot that point, we always start at the origin. We move positive 5 in the x, so that's to the right. So 1, 2, 3, 4, 5 to the right. And then up 5, 1, 2, 3, 4, 5. So this should be the point. Actually, I'll do it in red. This should be the point 5, 5. All right, so that's the point A. And then B is negative 3 in the x. So if I start at the origin again, I need to move to the left 3 and then up 4. So that would be right here. So this is the point B, and it has coordinates negative 3, 4. So if we look at the possible answers, it looks like B is the correct answer in this case. So we simply plotted those 2 points. Okay, that was question 1. All right, question 2. Was to simply identify which quadrant that this particular point of negative 20, negative 9 is in. And remember, when we have a coordinate system, right, the upper right is quadrant 1. In that case, the x coordinate is positive and the y coordinate is positive. Then we go counterclockwise. So upper left is quadrant 2. In this case, the x would be negative, the y would be positive. Then quadrant 3, here both coordinates would be negative. And then finally quadrant 4, where the x is positive and the y is negative. So in this case, negative 20, negative 9, this is going to be in the third quadrant. So this should be answer A in this case. Okay, question 3. We want to graph the line containing the points 2, negative 6, and negative 1, 3. And we also want to find the slope. So actually, let's find the slope first. So if I label these, remember the first point, you should label x1, y1, and in the second point, x2, y2. But it really doesn't matter which one you label the ones, which one you label the twos. So what I do is the first point I see, just label the ones. The second point I see, label the twos. And then remember to compute the slope, it's always going to be y2 minus y1, right? The change in the y or the change in the output over x2 minus x1. So change in x, right? Or change in the input. So change in y over change in x, or change in output over change in input. So in this case, it'll be 3 minus a negative 6 divided by negative 1 minus 2. And here we just have to be careful with signs. So 3 minus a negative 6 is the same as 3 plus 6, right? So that's 9. and then negative 1 minus 2 is negative 3, and then this will simplify to negative 3. So the slope is a negative 3, and then to actually graph this, we can just plot those 2 points, right, and draw a line through it. So let me move this, give myself a little room here. So here's the Cartesian coordinate system, and so x, y, and let's see, I have the point 2, negative 6. So I move 2 to the right, down 6. That's right here. And then the point negative 1, so 1 to the left and up 3. So right there. So the line is going to look like this. Looks like it goes right through the origin too, so it looks like this. Okay, so if you look at the answers, actually in this case you can get it just by looking at the slope, right? So the best answer is going to be D. The slope is negative 3, and that's the correct graph. Okay, question 4. So we're given a graph of, in this case, of a vertical line. And it looks like it's passing through, let's see, 1, 2, 3, 4, 5, 6. And then looks like 8 and negative 8. So 1, 2, 3, 4, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it looks like there's a point at 6, 8. Again, let me do that in red. So 6, 8, and then 6, negative 8. So this is the point 6, 8, and then 6, negative 8. And it's a vertical line, right, that passes through those 2 points. So we want to determine whether that the slope of that line is positive, negative, 0, or undefined. So this is one of our special cases, and actually we should know the answer without even doing any work. Remember, a vertical line has an undefined slope. Some people will say it's infinite, but to be more correct, we'd say that the slope is undefined. Another way of seeing that is, since we know 2 points, in fact, it's going to be 6 comma anything is going to be a point that lies on the line. But if we use the 2 points that are given, 6, 8, and 6, negative 8, we could just actually compute the slope as well. So that's another way of determining it. But we should know that we're going to get undefined. But let's actually compute the slope and make sure we get the same thing. So x1, y1, I'll label this x2, y2. So my slope is going to be y2 minus y1 over x2 minus x1. So here I have negative 8 minus 8, which is negative 16, over 6 minus 6, which is 0. And of course, anything divided by 0 is undefined. So we got exactly what we expected, right? Undefined slope. Vertical line has an undefined slope. So the answer should be B in this case. Okay, 5. So here they give us 4 points. So point P has coordinates 1, 9. Point Q has coordinates 5, 25. R has coordinates 12, 2. And S has coordinates 60, negative 10. And we want to determine whether the lines PQ and RS are perpendicular, parallel, or neither. So in order to figure this out, we have to calculate the slope of the line PQ and the slope of the line RS. Okay, so to do that, let's label these points. So P, I'll label the 1, so x1, y1. Q is x2, y2. So let's first find the slope of line PQ. So, of course, it's the usual, right? It's going to be y2, 25, minus y1, which is 9, over x2, 5, minus x1, which is 1. Well, 25 minus 9 is 16. 5 minus 1 is 4. And then 16 divided by 4 is 4. So it's positive 4. And then for the slope of the line RS, we use the points R and S, right? So again, you could label the R the 1s and the S the 2s. So in this case, it would be y2, which is a negative 10, minus y1, which is 2, over x2, 60, minus x1, which is 12. So negative 10 minus 2 is a negative 12. And then 60 minus 12 is 48. And then this simplifies, since 12 goes into 48 and 12 goes into 12, this simplifies to negative 1, 4. Okay, so now we have to look at this. And remember the conditions for two lines being parallel, perpendicular, and in neither. So in order for two lines to be parallel, the slopes would have to be equal. Well, clearly in this case, these slopes are not equal, right? So we have the first slope, the line PQ has a slope of 4, and the line RS has a slope of negative 1/4. So they're definitely not parallel, because those slopes are definitely not equal. To check whether they are perpendicular, we would multiply the slope of line PQ. So this is PQ times the slope of the line RS. And we're going to see what we get. If we happen to get negative 1, then we know those two lines are perpendicular. If we don't get negative 1, then the best answer would be neither, right? They would cross at some point, but they wouldn't cross at a 90-degree angle, at a right angle. They'd just cross any old angle. Okay, so let's actually multiply these two slopes together. So if I multiply 4 times negative 1/4, you can think of 4 as 4 over 1. Well, actually, in this case, right, the 4's cancel. And if you multiply that out, you get negative 1. So these two lines happen to be perpendicular. So in this case, the answer would be B. Right? Because the slope of the first line times the slope of the second line turned out to be equal to negative 1. So they were perpendicular. If we got something else, if we didn't get negative 1 here, then our best answer would be neither. But in this case, we got exactly negative 1. Okay, question 6. So we're given a linear equation. So y plus 4x is equal to 41. And we want to just complete the table. Okay, so they gave us a table here of x and y values. If x is 9, what's y? If x is 41, what's y? If x is 0, what's y? Okay, so really all we have to do is plug in, right? So if we want, we could even solve this equation for y, right? We could put it in the y equals mx plus b form. Might be easier to do that. So let me move the 4x to the other side. You don't need to do this, but so this will be negative 4x plus 41, right? I have to subtract 4x on both sides. And now all I'm going to do to finish filling in this table is to plug in those particular x values and find the corresponding y values. So for the first one, if x is 9, then I have what? Negative 4 times positive 9 is negative 36. And negative 36 plus 41 is a positive 5. So I guess this is going to be 5. if I plug in what's the next one? 41. So if I plug in 41, I have y equals negative 4 times 41 plus 41. Okay, so what's negative 4 times 41? That's negative 164, I guess, plus 41. And then that is going to be negative, looks like 123. So this is negative 123. And then finally, if I plug in 0 for x, so I have negative 4 times 0 plus 41. That's just going to lead to the solution y equals equal to 41. So this will be 41. So the table that matches that is table A. So the answer in this case would be A. Okay, question 7. They give us a linear equation, negative 2x minus 12y is equal to 12. And we want to find the x and y intercepts and then graph the equation. Okay, so remember the x-intercept, that is where the graph passes through the x-axis. So how do we find it? Well, we set y equal to 0 and we solve for x. Right, think of it if you had a little table here, you would set y equal to 0 and you'd figure out what the x value is, and that would be our x-intercept. So in this case, I'm going to plug in 0 for y, so I have negative 2x minus 12 times 0 is equal to 12. So that's just going to be negative 2x is equal to 12. If I divide both sides by negative 2, it looks like x is equal to negative 6. So the point negative 6, 0 is going to be my x-intercept. And then finally for the y-intercept, it's exactly the opposite, right? The y-intercept is where does the graph pass through the y-axis. So to figure that out, we have to set x equal to 0 and solve for y. Again, if we make a little table, right, that's if we force x to be 0 and we figure out the y is, that's got to be our y-intercept. So in this problem, it would be negative 2 times 0 minus 12 times y equals 12. So this is just negative 12y is equal to 12, right? Because negative 2 times 0 is 0. And then finally, to get y by itself, since I want a 1y, I have to divide by negative 12. Since it's being multiplied by negative 12, I undo that by dividing by negative 12. And whatever I do to one side, do the other side. So y is going to be equal to negative 1. So 0 comma negative 1 must be my y-intercept. Then they want us to also graph that. So I'll do that over here. Let me move this over a little bit. So here's my coordinate system. So x, y. Let's see, and all you really need to do is plot those 2 points, right? The x and y intercept, and then I can graph it. So negative 6, 0. If I start at the origin, I move 6 to the left, and then nothing on the y, so that's right on the axis itself. So right there. And then 0, negative 1 is nothing on the x, but down 1 on the y. So right there. So the line's going to look like this. So something like that. Should be a little straighter than that, but something like that. So it looks like the best answer here is C. So the correct answer is C. Okay, Number 8. Okay, so here we're asked to graph the line y equals 6. Remember, this is one of our special cases. You should just know this, right? If you have y equals a constant, it's going to be a horizontal line. Okay, if you forgot that, let me walk you through this one more time. Let's make a little table. First of all, let me draw my Cartesian coordinate system first. So x, y. Okay, remember, if we put this in standard form, we could write this as 0 times x plus 1 times y is equal to 6. So if we make a little table, it doesn't matter what x is. X can be anything. X could be -2, it could be 0, it could be 2, it could be 1,000,000, it could be anything. But then when I plug that in and solve for y, I'm always going to get y is equal to 6. Right? Because 0 times x here will always give me 0, and then I end up with y equals 6, regardless of what I plug in for x. So if we plot a few of those points, -2, so 2 to the left, up 6, right there, 0, 6, right here, and then 2, 6, right here, we're going to see that we're always going to get a horizontal line. Which, by the way, has slope 0, right? But they didn't ask for the slope, they just want us to graph the line. So it looks like in this case, C would be the correct answer. This is C. So y equals a constant is a horizontal line, x equals a constant is a vertical line. Okay, question 9. So we're given a linear equation, -4x plus 8y is equal to 8. And we're asked to find the slope and y-intercept of that line. So this linear equation right now is in the standard form. To find the slope and y-intercept, it's much easier if we can rewrite the equation in the slope-intercept form, which remember is the form y equals mx plus b. Because then we can just pick out the slope, right? That's the m. And then the b is the y-coordinate of the y-intercept, right? It's always 0, b. So if we find m and b, we have our answers. So how do I rearrange this equation to put it in this form? I simply solve it for y. So let me write down the equation again here. So -4x plus 8y is equal to 8. So I want to solve this for y, right? So I want to keep the 8y together on the left-hand side. I need to first get rid of the -4x, so I'm going to add 4x to both sides. So I have 8y equals 4x plus 8. And now I will divide by +8, right, both sides. So now I have y is equal to, I'll write this as 4x over 8 plus 8 over 8. But then I can simplify this a little bit, right? 4 over 8 is the same as 1/2 times x plus, and then 8 over 8 is 1. So what does this tell us? Well, it tells us the slope is 1/2. And it says, so remember the slope is right here. Right? It's the coefficient of the x term. And then the b is the 1 here, but that means that the y-intercept is going to be 0, b. So it's 0, 1. So in this example, B would be the correct answer. So this is B. Okay, number 10. Actually, number 10, they simply want us to rewrite the equation in slope-intercept form. So that's just solving it for y. Okay, actually, I think we did this example in a previous practice sheet. And in that case, I moved the negative 4y to the right-hand side just to make the coefficient of the y positive, to make it a positive 4. But actually, let me leave it on the left-hand side to show you that it'll work either way, right? So if I leave the negative 4y on the left-hand side, I would first start by getting rid of the 6x, so I need to subtract 6x. But I'll do that to both sides. So I have negative 4y equals negative 6x plus 3. And then finally, to get y by itself, I would divide by negative 4. So then y equals, and then you could write this as negative 6x over negative 4 plus 3 over negative 4. And then we can simplify, right? Negative 6 over negative 4 is the same as 3 halves times x. And then 3 over negative 4 is negative 3/4, so I can write this as minus 3/4. So that would be the correct equation. Again, it's the same linear equation as the one that was given. It just so happens that this one was in standard form, and this one now is in slope-intercept form. So the correct answer in this case is going to be C. We just rearranged it. The nice thing about this is we can easily pick out the slope and the y-intercept. Okay, 11. Find the equation of a line in slope-intercept form that satisfies the specific conditions. In this case, we want to find the equation of a line that passes through the point 2, negative 16, and negative 1, negative 4. So remember, to find the equation of a line, I need to find two things. I need to find the slope. I need to find b. So to do that, let's find the slope first. Since I'm given 2 points, right, I can label these as x1, y1, and then x2, y2. So to compute the slope, it's simply going to be y2, negative 4, minus y1, so minus a negative 16, over x2, negative 1, minus 2. So negative 4 minus a negative 16 is negative 4 plus 16, which is a positive 12. And then negative 1 minus 2 is negative 3, and this simplifies to negative 4. So the slope is negative 4. So I can fill that in, right? So I have y equals negative 4. I know that slope x, but I still don't know b, so I'll leave it as plus b. Now, how do we figure out b? We plug in one of the given points, and it doesn't matter which point we use. We can use either one. They both have to satisfy the linear equation, so because they both lie on the line. So both of them will allow us to find b. So let me just choose the second point to plug in. So y is a negative 4. X is a negative 1. So I have negative 4 equals, well, negative 4 times negative 1 is positive 4 plus b. And then finally, to get b by itself, I have to subtract 4 from both sides. So it looks like b is going to be negative 4 minus 4, which is negative 8. So now that I have both m and b, I'm done, right? So my equation must be y equals negative 4x and then minus 8, because b is negative 8. So it looks like the correct answer in this case will be C. Okay, 12. Let's see. They give us a graph and they want us to find the equation of that graph. Here, let me regraph it for you here. So it looks like this graph goes through the points negative 2, 0, and then 0, 3. So negative 2, 0 is right here, and then 0, 3 is right here. So it looks like this. All right, well, there's a couple of different ways you could do this. The easiest might be to just use these 2 points, right? Because again, we know 2 points the line lies on. In fact, it's the x and y intercept. So in this case, it's -2, 0, and 0, 3. So we could just label one of them x1, y1, the other one x2, y2, figure out the slope, and then we could figure out b. In fact, we already know b. B must be 3, right? Because that is the y-intercept. The other way that we could do this is we could say, okay, let me do a couple more tick marks here. We could say we know b, right? Because right off the bat, again, because since this is the y-intercept right there, b must be 3. And then I could figure out the slope by starting at that point, or starting at any point on the line. Actually, let's start at -2, 0. Let's start at this point. How do I get to another point on the line if I start at -2, 0? Well, remember the slope is equal to rise over run. That's another way of saying change in y over change in x. So y2 minus y1 is like the rise, and then x2 minus x1 is like the run. So I can think of this, well, if I start at -2, 0, what do I need to do? I need to go up 3. So my rise is a +3. And I need to go over 1, 2 to get back on the line. So my run would be a +2. So my slope must be 3/2. So that's another way to figure out the equation of a line given the graph. You could either use the 2 points and then do it like we've been previously, figure out the equation of a line given 2 points. Or we could reason, well, we know b because we know that y-intercept, we know the slope, so we have all the information. So the equation must be y equals 3/2 x plus 3. So in this case, it looks like it's A, be the correct answer. Okay, let's see. Number 13. So now we're given an inequality in 2 variables. So x plus 2y is greater than -6. And we want to know whether the point 3, -4 is a solution to that inequality. In other words, does the point 3, -4 lie within the shaded region? Okay. But we don't have to graph this or anything to figure that out. The easiest way to figure it out is to plug in that point and see if we get a true or false statement. So if I plug in, remember x is 3, y is -4. So where I have an x, I plug in 3. Where I have a y, I plug in -4. And I'll put a question mark here. Let's check to see if it's greater than -6. So 2 times -4 is -8. So 3 plus -8. So 3 plus -8 is -5. Is -5 greater than -6? Yeah, that's true, right? Because -5 lies to the right of -6 on a real number line. So this is true. Therefore, is 3, -4 a solution? Yes, it is a solution to that inequality. So the correct answer would be A in this case. It is a solution. Okay, 14, we're actually asked to graph now the inequality in 2 variables. So here we have -2x minus 4y is, let's see, less than or equal to 8. All right, so let me make some room over here. Draw on my coordinate system. So x, y. And remember how to do this. We first have to, right, there's several steps. The first step is to change the inequality to an equal sign. So now this just becomes the equation of a line. And we want to plot that line. right? They usually say plot the corresponding line. So how do we plot this line? Well, the easiest way to do it is make a little table. Choose an X or choose a Y and figure out the other coordinate, right, given one of them, and then we can plot those 2 points. So in this case, probably the easiest would be to use X and Y intercepts. So if I choose X is 0, right, and I plug that in, so negative 2 times 0 is 0, so I just have negative 4y is equal to 8. If I divide by negative 4, I have y is equal to 8 divided by negative 4 is negative 2. So y is negative 2. So basically that's the y-intercept, right? By the way, another quick way of doing this is if x is 0, then that means like this first term is gone. And then you can ask yourself, well, negative 4 times what will give me a positive 8? Well, negative 4 times negative 2 will give me a positive 8. Okay, so you can either reason it out if you have nice easy numbers, or you can actually just do it out. Plug in the x equals 0 and then solve it for y. And then probably a nice easy point to plug in or value to plug in is now y equals 0. So then I'm going to have negative 2x minus 4 times 0 is equal to 8. So negative 2x equals 8. If I divide by negative 2, then I have x is equal to negative 4. Okay, and again, you could just cover the second term and ask yourself, negative 2 times what will give me positive 8? Well, it must be negative 4. Okay, so let's plot these 2 points. So 0, negative 2. Is going to be right here. And then what was the other one? Negative 4, 0 is right here. So this line is going to look like this. I need to choose a test point, right, to test. Again, since it's available, let's use it. 0, 0. It's just easy to plug in zeros. So now I have to go back to the inequality, right? So I have negative 2 times 0 minus 4 times 0 is less than or equal to 8. Well, negative 2 times 0 is 0. Negative 4 times 0 is 0. So this is just 0 is less than or equal to 8. That's true. And since I got true, remember the side on which the test point lies, if you get true, that's the side that gets shaded. So this side should be shaded. So in this case, looks like the correct answer is C. C should be the correct answer. Okay, and then the last one, question 15. So it's another inequality. In this case, x is greater than or equal to 2. So here's my coordinate system. So x, y. So same as usual, I need to first change that to an equals. So x equals 2. And again, we could write it as, 1x plus 0 times y is equal to 2. Then if we make a little table, then we'll find that it doesn't matter what y is, x is always going to be equal to 2. Right? But it's easier if you just remember that whenever you have x equals a constant, we know that that is going to be a vertical line that passes through the point 2, 0, right? And actually it's always the coordinates of every point in that line are going to be 2 comma something. So if we graph this, let's see, 2, negative 2, 2, 0, 2, 2, 2, 5, 2, negative 4, etc. This is going to be the vertical line. And actually, if I'm being careful, since it's greater than or equal to, it should be graphed as a solid line. So something like that. Now I want to figure out what side to shade, so I pick a test point. Again, let's just use 0, 0. So now if I go back in and I plug in 0 for x and 0 for y, well, there is no y, so I don't have to worry about it. So 0 for x is greater than or equal to 2. That is false. So therefore, the opposite side, right, this side should be shaded. So it should look like this. So in this case, it looks like D would be the correct answer. Okay, and remember, in most of our examples, it just happened to turn out that the inequality was less than or equal to and greater than or equal to. Remember, in that case, that's when you draw a solid line. And then if we have strictly less than or strictly greater than, so there's no equal to, then the line would actually be a dashed line. Actually, let me do it in blue. And that just means that the solution doesn't contain the line itself, right? The points on the line itself are not solutions to the inequality. In this case, where we have a solid line, these are the points right on the line itself are also solutions because we have the equal to, but in a dash case, they would not be solutions. Just everything else in the shaded region, not right on the boundary itself. Okay, great. So that's the practice for exam 2, and that should get you ready for the second exam, which is going to be on MyOpenMath.